So, to give a brief introduction to myself, I'm Reace Edwards, and I'm doing a PhD in chemical engineering here at the University of Chester, which, as you've probably guessed by the title on the screen behind us, is concerned with hydrogen. So don't worry, I'm not going to bombard you all with countless figures and statistics. I'm going to try and make this as interesting as possible. So you'll notice I've titled this presentation, Our Journey to Decarbonisation, and I'm hoping that by the end of it you're going to understand exactly why that is. So on the screen here, we've got 4 images. We've got a car, a refuelling station, a combi boiler, and a gas hob. Now, you're all probably wondering, what on earth do these have in common? And why am I looking at photos of appliances that I use day in, day out in my day-to-day life? And that in itself is the exact point of this presentation. And I'm going to explain exactly what I mean by that throughout. So I do apologise if the use of clip art is offending some members of the audience, but we're going to be referring to these images a few times, so I do apologise. So before we get started, I'm just going to talk about what I'm going to be covering. I'm going to be talking about why we need to decarbonise, what the heaviest emitting sectors are, and how hydrogen technology could be deployed to reduce these emissions. So let's dive into it. Okay, so I'm going to highlight the urgency for decarbonisation using these 2 graphs on the screen here. So what you'll see on the left-hand side is the increase in carbon dioxide emissions in the atmosphere since the pre-industrial era. So you'll see this massive increase shown by the grey section, and that's the result of anthropogenic activities. So this is from processes like fossil fuel combustion and cement production. So before I go on to explain the next graph, I'm just going to give some context as to why this is so bad. So put simply, carbon dioxide is a greenhouse gas. And greenhouse gases are happy to absorb infrared radiation from the sun. And this in turn reduces the amount that's reflected back into space. This warms the atmosphere and induces changes on the climate system. So because of this, in recent years, we've seen that sea levels have risen and we've seen that glaciers have shrunk. But it's also having an effect on our extreme climate. And this is causing extreme events which are increasing the vulnerability to human systems. So to give some context as to why this is so severe, a recent extreme event in 2003 was a heat wave and drought that struck Europe. And this event alone left an estimated death toll of 30,000 lives. And I'm pretty sure that some members of the audience will be able to think of more recent events that have also caused death. So if we keep emitting this carbon dioxide into the atmosphere, then these events are obviously going to keep occurring. So I'm now going to turn your attention to the graph on the right-hand side of the screen there. And this graph was released earlier this year, actually, in January time, from the Met Office. And what that's shown is that the concentration of carbon dioxide in the atmosphere is expected to increase more this year than it has done for the previous 2 years. So I'm hoping that now you can see why we need to decarbonise and why it is that we need to act now. Okay, so I'm going to introduce the UK's largest emitting sectors, and some of these results might come as a little bit of a shock to some of you. So the graph that you're looking at here shows the UK's total contribution towards carbon dioxide emissions from individual sectors. So this includes the energy supply, business, transport, public, residential, etc. So the red bars show what these looked like in 1990, and the pink bars show what they looked like in 2017. So as you can see, and what you probably all predicted, the energy supply sector contributed the most towards emissions in 1990. And this was a result of the country's heavy dependence on coal. However, since then, renewable energy technologies have been integrated into the energy supply mix. And in 2015, the government announced the plans to close all unabated coal power plants by 2025. And since this announcement, multiple plants have actually shut down. So the results of this are reflected in the pink bar, which shows a 13% reduction in the contribution from the energy supply sector. But perhaps what's most interesting is the trends that you're seeing in the transport and the residential sector there. So now in 2017, transport becomes the heaviest emitting sector. And the residential sector is actually equal to the contribution from the business sector, which, as you can see, wasn't the case in 1990. So going off the previous images and the information that I'm giving you here, you can probably see where this presentation is going. And yes, you guessed it right, we're back to these images again. So what I'm going to do through this slide is try and show you how these images relate to the data I've just given you there. Although at this stage, the refueling infrastructure isn't actually relevant. But there is one thing that the car, the combi boiler, and the gas hob have in common, and that's a combustion reaction. So when a fuel, whether it be petrol or diesel from your car, or natural gas from your boiler or your hob, reacts with oxygen, this releases carbon dioxide emissions, which, as you know from what I've just said, is obviously a bad thing. So now I'm going to give you some hard-hitting figures. So for every kilometre that is travelled in an average car, 122 grams of carbon dioxide are released. So you're probably thinking that's not that bad, is it? But if you use the European average, which is approximately 12,000 kilometres a year, that leads to 1.5 tonnes of carbon dioxide emissions per year. So then, if on top of this, you're also using a combi boiler powered by natural gas to heat your home, that's an extra 4.5 tonnes of carbon dioxide you're emitting. And then even on top of this, if you use appliances like a gas oven and a gas hob, that's an extra 38 and 71 kilograms of carbon dioxide. So in total, that's approximately 6.1 tonnes of carbon dioxide emitted per person per year. So I know this won't be the case, but let's say for simple maths that it is, if this applied to all 100 members of the audience, that's 610 tonnes of carbon dioxide that are being emitted per year just from this room alone. So now you can really start to see how all of these individual emissions begin to build up and equate to the amount that we produce globally and emit annually. So I'm not trying to be completely doom and gloom, so let's flip it the other way around. Instead of thinking about the amount that we do emit, why not think about the amount we could save if we swapped to low-carbon alternatives? And for this reason, I'm now going to be introducing hydrogen and how hydrogen technologies could be deployed in these heavy emitting sectors. So to avoid bias, I'm going to give this introduction from both sides of the coin. So on the top left here, these are probably the three most common statements you'll see from any organisation that tries to promote hydrogen. So number one, you've got hydrogen is the most abundant element. And yes, this may be true, but hydrogen reacts readily and is often found in other compounds. So this means that a large amount of energy is required to get the hydrogen in its molecular form. Statement two, hydrogen has a higher energy content than any other fuel. And once again, that is completely true, but this is referring to its gravimetric energy density. And in reality, its volumetric energy density is very small in comparison. So what I mean by that is that you only actually get a small mass of hydrogen per unit volume compared to any other fuel. Statement number three, hydrogen is a clean fuel. And once again, that's completely correct, but only when burnt with pure oxygen, because this releases only water vapour. However, in reality, and in most scenarios, hydrogen is going to burn in air. And as we know, air is 78% nitrogen. So this leads to the formation of NOxes, which are a major air pollutant. But then again, so does any other fuel that burns in air. So although it might seem like it, the purpose of that wasn't to slate hydrogen. It was actually to say that like any other fuel, it does have its disadvantages, it does have its drawbacks. But the good thing about hydrogen, with regard to decarbonisation, is that these are minimalistic in comparison to other fuels. So I'm now going to refer to this little recent study here. And this found that 6 gigatons of carbon dioxide emissions could be reduced annually if we switched to hydrogen. So to put that in perspective, that's 1 billion times more than the emissions that we could have individually saved earlier. So to answer the question, is hydrogen a dream or reality? I'm going to refer to this graph on the right here. So this shows the hydrogen demand across industry. So as you can see, it's already got huge demand in the refining and chemical industries. And in Europe alone, 45 million tonnes of hydrogen are consumed annually. So in my opinion, yes, I think if we've got this production technology that's producing 45 million tonnes a year, there's no reason why we can't scale this up and use it to decarbonise heavy emitting sectors. And I know it will be a bit of a challenge, but I think it's definitely possible. So that was a very brief introduction to hydrogen there, but what I want to talk about now is how it can be used in those sectors that we can each individually help in decarbonising. So yes, we're back to these images again, and this time you'll be happy to know that they're all applicable. So you've got your car on the top left here. So hydrogen can be used to decarbonise the transport sector using fuel cells. So basically, a fuel cell converts chemical energy from hydrogen and oxygen into electrical energy. And this in turn powers a vehicle's traction motor, which allows the car to move itself. So I've got a photo of a car on the screen here. However, this can be used in many vehicles. So you can actually use it in heavy goods vehicles, trains, buses, and even forklifts. So you're probably wondering why have I got a photo of a refueling station? Well, this is what actually a refueling station for a hydrogen fuel cell vehicle would look like. So it would be very similar to your typical diesel or petrol car. And in addition to this, the refueling time is approximately 3 minutes. So that's also very similar compared to other low-emission vehicles, which require significant charging times like battery-powered vehicles. And in addition to this, for a full tank of hydrogen, you're looking at approximately 312 miles of driving range, which isn't that bad compared to your normal vehicle. So when looking at the domestic sector, the way we use hydrogen in our appliances wouldn't actually be that different to what we used to too. However, in this sector, the initial role of hydrogen is not so certain. So you've got some studies that are looking at putting a blend of hydrogen with natural gas into our gas supply. So this would mean that we wouldn't need to change any domestic appliances. But because we've still got natural gas present, that means that carbon dioxide emissions, yes, lower, would still be there. So therefore, to tackle this problem, you've got other studies that are looking at testing 100% hydrogen in our household appliances. But this would mean that we would have to install new appliances to accommodate hydrogen as opposed to natural gas. So as you can see there, you've got a bit of a trade-off between emission reduction and the inconveniences and costs of installing these new appliances. So I'm sure you're all sick of us hearing talking about studies and initiatives, so I'm actually going to show you some of them now. So on here, at the top left-hand corner here, we have the world's first hydrogen-powered train. So this was designed by a German company called Alstom, and this entered commercial operation in Germany in June 2018. And underneath this, we have the Toyota Mirai, which is the world's first mass-produced hydrogen fuel cell vehicle. And this was commercially available in the UK from 2016. And it's not the first of its kind either. And to the right-hand side here, at the top right, as I mentioned earlier, this is a hydrogen fuel cell in a forklift. So these are actually a lot more popular than you might think. So in the US alone, there's 20,000 of these forklifts in operation. And the main application is in warehouses. So underneath this, I also mentioned hydrogen in buses. So this initiative is a bit closer to home, and this is a bus in London, actually, a hydrogen fuel cell bus. So in London, there's currently 8 of these buses in operation, and with 5 refueling stations. So in the middle here, what you see is the studies that are looking at the domestic appliances that I mentioned earlier. So you've got High Deploy. So that is testing a 20% volume blend of hydrogen with natural gas. And that's currently underway at Keele University at the moment. But if this proves to be successful, it'll go to 2 further public trials on public gas networks in the north of England. And under this here, you've got High for Heat. And they're the ones I was telling you about that are looking at converting to 100% hydrogen. So them ones there are testing the practicality and safety of hydrogen in both domestic and commercial appliances. And once again, if this proves successful, it will go on to a public trial. So really, this is only a tiny reflection of the amount of hydrogen initiatives that are going on at the minute. And I could sit and talk to you all day about them, but unfortunately I don't have the time to do that. So to conclude, I'm going to pose the question, is a hydrogen future closer than we may think? Now, in my opinion, yes, because this is what the PhD is on. But it's a question that I'd like you to answer yourselves. So not immediately, maybe not today, maybe not tomorrow, but it's something I'd like you to go home and think about using the information I'd give you. I'd like you to think about the following 3 questions. So what do you think your individual role in decarbonisation will be? Can you imagine driving around in a hydrogen fuel cell vehicle anytime soon? And can you imagine your appliances at home powered by hydrogen? And then only once you start thinking about these things, might you start to form your own opinion and answer the question, is a hydrogen future closer than we may think? Thank you.